बिस्मिल्लाहिर्रहमानिर्रहीम अल्लाहुम्मा सल्लि अला मुहम्मदिन व अला आलि मुहम्मदिन व बारिक वसल्लिम रब्बि इश्रह ली सदरी व यस्सिर ली अमरी वहलुल उक़्दतम मिन लिसानी यफ़क़हू क़ौली। Assalamu alaikum. I am Dr. Umar Farooq, Division Public School and Intermediate College, Lahore, and I'll teach you chemistry. First of all, I would like you to know the pattern of chemistry paper. There will be a 60 marks paper, 12 marks for objective and 48 marks for subjective. Time allowed for objective is 15 minutes and 1 hour 45 minutes for subjective. This makes a total of 2 hours time. In objective, we have only MCQs. You have to attempt 12 out of 12 MCQs. No choice. So MCQs have 12 marks. The subjective part 1 comprises of question number 2, 3 and 4. Each consists of 8 questions and you have to give short answers of any 5 of these. Each short question carries 2 marks. And you have to attempt 15 short questions altogether out of 24. So 15 short questions have total 30 marks. In subjective part 2, we have extensive questions or essay type questions, often called long questions, comprising of question number 5, 6 and 7. Each of which consists of A and B parts, A of 5 and B of 4 marks. You have to attempt 2 out of 3 long questions, each carrying 9 marks. So 2 long questions have 18 marks. Physics and biology have the same paper pattern. So, what is chemistry? Chemistry is a branch of science which deals with the study of composition of matter, properties of matter which are of 2 types, physical properties and chemical properties, changes in matter which are also of 2 types, physical changes and chemical changes, and structure of matter. In short, chemistry is a study of matter. You see the word matter repeatedly in the definition of chemistry. Let me remind you what is meant by matter. As you have studied earlier, anything which has mass and occupies a space is called matter. There are 4 states of matter: solid, liquid, gas, and plasma, which is the most common state found in the universe. Let's have a look at the definition of matter again. I'm gonna rewrite it by highlighting some of the words, and those are mass and volume. Mass is the quantity of matter which a body contains, whereas the space occupied by an object is called its volume. The SI unit of mass is kilogram, whereas the SI unit of volume is meter cube or cubic meter. Other units of volume which are commonly used are cubic decimeter, also called liter, and cubic centimeter, which is also called milliliter. Now, a question arises: what is matter composed of? Obviously, chemistry has the answer, as it deals with the study of matter. Let's remove the last 3 points, as we are interested in the first one, that is, how the matter is composed. Experiments have revealed that every matter consists of very tiny particles. These particles may or may not exist freely. By free existence of a particle, we mean that the particle can exist alone as a single unit without depending on other particles. And if a particle does not exist freely, it means that the particle is unstable as a single unit and exists only by combining with other particles. By this time you have come to know that all matter consists of very tiny particles which may or may not exist independently. And these particles are atoms, ions, molecules, and formula units. We shall now try to understand what these particles are. First of all, atom. An atom is the smallest particle of an element which may or may not exist independently or freely. Only the atoms of noble gases exist independently, whereas the atoms of rest of the elements do not exist in free state. Such atoms either form ions, molecules, or formula units, which will be discussed later. Here is an animation showing the structure of an atom. You can see some tiny particles are revolving around a central bigger particle. The tiny particles are called electrons, and the central particle is called the nucleus. The path in which an electron moves is called its orbit or shell. The central body nucleus seems to be a single particle, but actually it is not. It rather comprises of two types of particles, protons and neutrons. So there are three fundamental particles in an atom. The positively charged particle is called proton. The neutral particle is called neutron. The negatively charged particle revolving around the nucleus is called electron. And the path of the electron is called its shell. Remember that there are equal number of electrons and protons in an atom. That's why it is always neutral and carries no charge. The properties of the fundamental particles of an atom are summarized in this table. A proton carries positive charge and has a unit mass, while neutron has no charge and has mass approximately equal to the mass of a proton. And electron carries negative charge and its mass is negligible as compared to the mass of a proton or the mass of a neutron. Let us now define two important terms related to an atom: atomic number and mass number. Atomic number is the number of protons in an atom. That's why it is also called proton number. It is denoted by capital Z. Consider, for instance, this atom. Here we have 2 protons. So its proton number or atomic number is 2. Now we move on to mass number, which is the sum of protons and neutrons in an atom. It is denoted by capital A. Mass number is also called nucleon number, because nucleon is the collective term used for the particles which make up the nucleus. If you look at the diagram, there are 4 nucleons, 2 protons and 2 neutrons. So the mass number of this atom is 4. Atomic number of an element is actually its identity number. That is, an element is identified by its atomic number. Atomic number is as significant for an element as fingerprints for a human being. Since every human being has unique fingerprints and no 2 persons in the world have the same fingerprints, so they are a person's recognition by which we can identify him or her. Similarly, every element has a unique atomic number and no 2 elements have the same atomic number. That's why it is the identity of an element. An element is represented in terms of its atomic number and mass number as follows. Atomic number is written in the subscript of element symbol, while that of mass number is in the superscript. In a helium atom, there are 2 protons, so its atomic number is 2. which is written in the subscript of its symbol. There are 2 neutrons as well. So its nucleon number or mass number is 4, which is written in the superscript of its symbol. Here we have some more examples. In nitrogen, there are 7 protons and 7 neutrons. So its mass number is 14 and atomic number is 7. In an oxygen atom, there are 8 protons and 8 neutrons in its nucleus. So its atomic number is 8 and mass number is 16. Now we write the relation between atomic number and mass number. Since mass number is the sum of protons and neutrons, in symbols A is equal to Z plus N or N is equal to A minus Z. For example, if you want to calculate the number of neutrons in uranium-238, write its atomic number, that is 92 of course. Its mass number is 238. So the number of neutrons is equal to 238 minus 92, which is 146. An important information about atomic number and mass number. Atomic number of all the atoms of an element is same, but mass number of all the atoms of that element may not be the same. Such atoms of an element are called isotopes, which is defined as atoms of the same element which have same atomic number but different mass number are called isotopes. Look at this atom and this atom and this. Do you see any difference? Of course not. As you can see, there is 1 proton and 1 electron in each atom. So atomic number of each atom is 1. These are of course atoms of hydrogen, and atomic number is written in the subscript of each of them. Now let's count the number of neutrons in each atom. There is no neutron in the first atom. There is 1 neutron in the second atom. And there are 2 neutrons in the third atom. So the mass number of first atom is 1 plus 0 equals 1, written in the superscript of the symbol of hydrogen. Mass number of the second atom is 1 plus 1, that is 2. Mass number of the third atom is 3. So these 3 atoms are the isotopes of same element hydrogen, having same atomic number but different mass number. These are given special names. That is, hydrogen 1 is called protium, hydrogen 2 is called deuterium, whereas hydrogen 3 is called tritium. Now look at these atoms. Each atom has 6 protons in its nucleus. So these are the atoms of carbon. And of course, each one has 6 protons in their orbits. There are 6 neutrons in the first atom of carbon, 7 neutrons in the second atom, and 8 neutrons in the third atom. So the mass number of first atom of carbon is 6 plus 6 equals 12, which is written in the superscript of its symbol. Mass number of the second atom of carbon is 13, and mass number of third atom of carbon is 14. They are called carbon 12, carbon 13, and carbon 14. Isotopes of chlorine. Chlorine has 2 isotopes. Each one has 17 protons and 17 electrons in all of its atoms. In one of its isotopes there are 18 neutrons and in the other there are 20 neutrons. So the mass number of one isotope of chlorine is 35 and the other isotope is 37. One isotope is called chlorine 35 and the other is called chlorine 37. It is concluded that isotopes are formed due to different number of neutrons in various atoms of an element. If you have any questions, please do write in the comments below. Thank you.